Welcome to this training session on rivet repairs, making countersink holes. While it might seem like using a countersunk rivet the best choice, especially on faster flying aircraft, an improperly made countersink reduces the strength of a flush-riveted joint and may even cause failure of the sheet or the rivet head. Machine or drill countersinking and dimpling or press countersinking are the most common methods used for flush, countersink, riveting. The proper method for any particular application depends on the thickness of the parts to be riveted, the height and angle of the countersunk head, the tools available, and accessibility. When using countersunk rivets, it is necessary to make a conical recess in the skin for the head. The proper degree and diameter countersink and cut only deep enough for the rivet head and metal to form a flush surface. When using a countersunk rivet there are other considerations. The countersinking process necessitates an increase in the number of fasteners to assure the required load transfer strength, because some material is removed in making the conical recess. Countersinking is done on metal below a certain thickness. A knife edge with less than the minimum bearing surface or actual enlarging of the hole may result. Edge distance must be greater as opposed to a universal head. Additionally, it has been found that countersunk holes have been responsible for fatigue cracks in aircraft pressurized skin. Pressurization cycles, fatigue and knife edges, mentioned earlier, are just some of the reasons for cracking on aircraft of this. Pressurized aircraft manufacturers are currently recommending the countersink depth be no more than 2/3 the outer sheet thickness or down to 0.020 inch minimum fastener shank depth, whichever is greater. Dimple the skin if it is too thin for machine countersinking. Here is an example. While there are many types of countersink tools, the most commonly used has an included angle of 100 degrees. Sometimes types of 82 degrees or 120 degrees are used to form countersunk wells. A six-fluted countersink works best in aluminum. There are also 4- and 3-fluted countersinks, but those are harder to control from a chatter standpoint. A single flute type, such as those manufactured by the Weldon Tool Company registered trademark, works best for corrosion-resistant steel. Chatter results in a countersink with a ragged edge and an inner surface that is chewed up in an undulated pattern. Before you start, always practice on a piece of scrap of the same type size as the repair material. To eliminate chatter, operate at a slow speed, 60 rpms or less. Use a sharp flute and have an undersized pilot hole. Machinists note that a 3-fluted require a pilot hole. If you still have chatter, try a different flute on your practice piece. The micro-stop countersink is the preferred countersinking tool. It has an adjustable sleeve cage that functions as a limit stop and holds the revolving countersink in a vertical position. Its threaded and replaceable cutters may have either a removable or an integral pilot that keeps the cutter centered in the hole. Dimpling is the process of making an indentation or a dimple around a rivet hole to make the top of the head of a countersunk rivet flush with the surface of the metal. Dimpling is done with a male and female die, or forms, often called punch and die set. The male die has a guide the size of the rivet hole and is beveled to correspond to the degree of countersink of the rivet head. The female die has a hole into which the male guide fits and is beveled to a corresponding degree of countersink. Rest the female die on a solid surface. Then, place the material to be dimpled on the female die. Insert the male die in the hole to be dimpled and, with a hammer, strike the die until the dimple is formed. 2 or 3 solid hammer blows should be sufficient. You can also use a hand squeezer. In subsequent sessions we will learn more about types of dimpling. This concludes this training session. We hope you found it useful.